Let's practice a multi-step factoring together. So in number one, we have this 3x squared plus 51x plus 216. When we're factoring these types of expressions or these polynomials, we always want to look for a GCF first here. I think that all three of these terms are divisible by 3. The divisibility rule is if you add up all the digits and that sum is divisible by 3, then you can divide that whole number by 3. So 3 times x squared is just 3x squared. 3 times 17 is going to be 51. So it's going to be 17x here. And then let's see, I know 3 times 70 is 210, so I think it's 72 here. So I'm going to go with plus 72. All right, so we factored out a GCF, which is going to be 3, but then inside here we're left with a trinomial, right? So we have a value of 1, so 1 times 72 is going to be 72. So if we go ahead and factor, we know we're looking for a positive 72 in terms of what we're multiplying to get here. But what about what are we adding to get? Well, we have this positive 17 here. So I'm going to go ahead and put the 17 over here. And I think two numbers that would multiply to get positive 72 but add to positive 17 are going to be 8 and 9. But you might need to sit there and go through some of your factors for a bit. All right, so I'm going to keep this 3 on the outside, and I'm actually just going to use a bracket here to stay a little bit more organized. And I'm going to go ahead and take this x squared, and then I'm splitting this 17x into plus 8x plus 9x, and then plus 72. So going ahead and just factoring this stuff out a little bit more clearly. Let's see, we have 8x and 9x. If we factor by grouping here, right, we can group these first two and group these last two and go ahead and factor out GCF. So we have 3 out here. That was what we had originally. Don't worry about that part too much. Factor out an x, so that's going to be the quantity of x plus 8. And we can factor out a 9 here. If we do that for the second grouping, this would be x plus 8. And so this looks like it's working out really nicely. Notice we have this, I'll go ahead and highlight to make it more clear, I guess, this x plus 8 and x plus 8 in both of these. And so let's go ahead and just leave this x and 9 alone here for a moment. The 3 is going to stay out here in front. And now we're going to go ahead and multiply this by, let's say they had the x plus 8s in common. And then they had these x plus 9s kind of left over as the other parts of the factors there. So this is kind of what that's looking like. The x plus 9 you can see over here. And then they had those x plus 8s in common. In the end, you can kind of just simplify this though and say it's going to be 3 times the quantity of x plus 8 multiplied by the quantity of x plus 9. I think this would be a great final expression here that we factored completely. All right, let's try another one together. All right, in number 2, you can look at all three of these terms. They all are divisible by 5 and also negative 5, I guess, right? We like to factor out negatives if we can, especially if a is negative. And they actually all have an x as well. So I'm going to go ahead and factor out negative 5x as the GCF to kind of start here. If we do that, we're going to be ending up with a positive 1x squared, and then it's going to be minus 9x, and then it's going to be plus 18, I believe. Yeah, that seems right here. Feel free to redistribute though, just to double check. Okay, so this right here is a GCF we pulled out first, and then here we have a trinomial left that we're going to try to factor. So notice how this a value is 1 inside this trinomial, so 1 multiplied by 18 is going to be 18. So let's go ahead and factor this thing, right? So 18 is going to be what we're looking to multiply to get. This negative 9 is the value for b, so we're going to put negative 9 inside here. So we're looking for two numbers that multiply to 18 but add to negative 9. I'm thinking negative 3 and negative 6 would do the job nicely here, right? So let's do negative 5x multiplied by, we have this x squared. Let's go ahead and do minus 3x minus 6x. Those are going to combine to make that negative 9x, right? So we're just kind of manipulating the expression a bit so we can factor a little easier. And at this point, we can go ahead and factor by grouping. So I didn't use brackets yet, but I'm going to do it now. I think it's going to be a little bit more clear for me. So I'm going to put a bracket here. If we factor by grouping, you can see what that's going to look like here. Let's factor out a x from this first part. So it's going to be x multiplied by the quantity of x minus 3, right? And then I think we can do minus 6 here. And if we do that, it's also going to be x minus 3. Okay, so just be careful with that minus here. So it might be confusing as to why this plus went to a minus, but keep in mind that there's a minus over here that's being distributed to both of these. So you have to remember to flip that sign there. Okay, this works out really nicely. Notice this x minus 3 and x minus 3, and then we have this x and then minus 6 here. So similar to the last example here, we have negative 5x out in front, and then we're going to have what after that? Well, we can go ahead and say, well, they had these x minus 3's in common, so we can factor that out, and then we're going to be left with this x minus 6. Okay. So notice we have the x minus 6 over here, and the x minus 3 is what they had in common. And then the brackets really aren't necessary. In the very end, you can just say this is negative 5x multiplied by the quantity of this x minus 3 times this quantity of x minus 6. So this would be our expression completely factored. All right, for our third example here, we have 45x to the 11th power minus 20x. So let's look at these two terms, what they have in common. I think we can divide them both by 5, right? And I think we can divide them both by x as well. So let's take that out as a GCF here. And if we do that, we're left with 9x to the 10th power. It's a pretty high exponent, but hopefully it's not going to be too intimidating. And then it's going to be minus 4 here. Okay, so in the last couple examples, we had a trinomial inside the parentheses. Right now, it looks like we have a binomial, but hopefully this looks familiar, or maybe a pattern with quadratics. This is a perfect square minus a perfect square, so this is a difference of squares pattern. So the square root of this is going to be 3x to the 5th power, and the square root of 4 is just going to be 2. So hopefully this kind of brings back some memories with quadratics of difference of squares, but this will turn into factoring this as 3x to the 5th power plus 2. And then you're also going to write 3x to the 5th power minus 2. All right, so this is a very specific pattern that you want to kind of remember. If you want to write this on the side here, if we have something like a squared minus b squared, that's a difference of squares. That always turns into the quantity of the sum of their square roots multiplied by the difference of their square roots. So in this particular case, you can see that a's value, I guess, would be 3x to the 5th power. That's what a is, squared, and that's where you get the 9x to the 10th power. And it's minus, and the square root of 4 is going to be 2, so it's really 2 raised to the 2nd power. So hopefully you can see where this pattern comes from, and if you need a quick refresher, hopefully that helps you. But whenever you have a difference of two perfect squares, you can just write it as a sum of their square roots multiplied by the difference of their square roots. This would be our completely factored form. All right, let's check out a fourth example here. Looking at number 4, we have this negative 2x cubed plus 30x squared minus 52x. I think we can divide all these terms by negative 2. I'll go ahead and pull out a negative 2 in front here, and I think they all have an x, so let's go ahead and pull out x as well. If you do that, we're going to be left with positive 1x squared, and then it's going to be minus 15x, and then it's going to be plus 26, I believe. Okay, so back to having trinomials again here. Here's our GCF we started with, and now we have a trinomial. We generally like it when a is equal to 1, so this is going to be a little bit nicer for us. So let's go ahead and see if we can factor this trinomial here. If we know a is 1, a multiplied by c, 1 times 26 is 26. So we know we're going to multiply to try to get 26. But what are we going to try to add to get? Well, that's where this negative 15 comes into play. So we're going to try to add to get to negative 15. I think I'm going to go with a negative 2 and a negative 13, right? I think negative 2 and negative 13 will multiply to get positive 26, but add to get to negative 15. So I'm going to keep this negative 2x on the outside. I'm going to remember to put my bracket out here this time. Doesn't really matter, but it's up to you. I'm going to keep this x squared here, and then let's split this into minus 2x and minus 13x, and then keep that plus 26 over here. Okay, so we're just kind of splitting that negative 15x into these two terms here to help us out a little bit. Now, if we factor by grouping, we can look at these first two terms and these second two terms. Be careful of that minus sign in the second one, but we have this negative 2x, and then if we factor out a GCF from the first grouping here, that's going to be x times the quantity of x minus 2. And then for the second grouping, if we factor out a negative 13 here, then it's going to be this positive x, but then it's going to be a minus 2. So just like one of the earlier examples, make sure you flip that second sign. Notice after we factor by grouping that we kind of have these two x minus 2's in common, which is really nice. And then we're left with this x minus 13. So keep this negative 2x out in front. And then they had in common was this x minus 2. And then we were left with this x minus 13 here. Okay, so the x minus 2, we are hoping that they come out unmatched so we can factor like that. And then we're kind of left with this x minus 13 here. So our final factored expression here is negative 2x. The brackets aren't necessary. I just like putting them for organizational purposes, but you don't have to write those, okay? And this would be our final expression. All right, for number 5, we have another trinomial here. So we have 5x to the 4th plus 35x cubed minus 150x squared. I think we can divide these all by 5, so let's pull that out as part of the GCF. And I think we can also pull out x squared as well. So if we do that, we're going to be left with, I think, x to the 2nd power plus 7x and then minus 30. All right, cool. So we have our GCF on the outside. A is now 1 for our trinomial, so 1 times this negative 30 is negative 30. So let's go ahead and see if we can factor this. Not too bad. So negative 30 is what we're multiplying to get, but what are we adding to get? We're looking for this positive 7. So let's go ahead and put a positive 7 here. I'm thinking here of positive 10 and negative 3. Those multiply to negative 30, but they also add to get this positive 7, so that works out really well here. So let's keep this 5x squared out in front. It's going to come along for the ride here. And then let's have this x squared, and let's split the 7x into plus 10x minus 3x. And then we have this minus 30 at the end here, okay? All right, cool. So we just kind of took that 7x and split into these two pieces. Let's go ahead and now factor by grouping. Let's group these first two and group these latter two. And let's keep this 5x squared again out in front here. Now a GCF of x squared and plus 10x is just going to be x. So we're going to factor that out. We have x plus 10. And then for this next piece, let's go ahead and take out a negative 3. And if we do that, we're going to get x, and then this is going to turn into a plus 10 so that everything matches. And if you distribute, you get the same thing that we started with here. Okay, again, this would be negative 3x, which matches here. This would be negative 30 if you multiply, which is what we have here. So notice how the x plus 10s match here. So you can go ahead and keep factoring. And then we have these x minus 3 here as well. So let's take this 5x squared and leave that there. And then let's go ahead and bring out the x plus 10, which is what they have in common. And we have this x minus 3 as well here. So I'm going to go ahead and just highlight these to hopefully make it a little bit more clear where everything's coming from. And then finally, we can just say this would be 5x squared. I'm going to drop the brackets and write x plus 10 and then x minus 3. So these are going to be our 3, I guess, factors here. All right, that would be as factored as we could go with this expression. All right, here is one final example. In number 6, we have, looks like just 2 terms here. So we have 81x to the 4th power minus 1. So this kind of reminds me of number 3. So if you want to try to look back at that one, this 81x to the 4th power is a perfect square, right? The square root of it would be 9x squared. And then this 1 is definitely a perfect square. The square root of that is just going to be a 1. So this is a difference of squares pattern like we had before. So when we have this difference of squares pattern, we're going to go ahead and add their square roots. So the square root of 81x to the 4th is going to be 9x squared. And then the square root of 1 is just 1. So here's us adding their square roots. And if we're going to go ahead and subtract their square roots, it would just be 9x to the 2nd power minus 1. So notice right here, this is our difference of squares pattern. And if you wanted to go ahead and just for good measure, redistribute this out, you're going to notice that the outer and the inner terms are actually going to cancel out because they're opposites, and you'll get 0. And you'll just be left with this 81x to the 4th power minus 1. Now, a lot of people do stop here and they don't check to see if you can factor more. Over here, we're kind of stuck and we are done. But if you look carefully at this second binomial, this is actually another difference of squares. 9x to the 2nd power, the square root of that is going to be 3x. And square root of 1, as we said earlier, is just going to be 1. So we can actually leave this 9x to the 2nd power plus 1 out in front here. But for this second binomial here, I'm actually going to go ahead and just, highlight it in red so you can see that we can actually keep going. And if we go ahead and do that, the square root of 9x squared is going to be 3x. So the sum of the square roots are 3x plus 1. And the difference of the square roots of this is going to be 3x minus 1, right? So hopefully you can see that it's kind of like a difference of squares inside of a difference of squares here. So it doesn't really matter. I guess we could box this, but I'm just going to kind of write it one more time to make it a little bit more clear. since I just did all that highlighting. So this one can't go any further. There's no sum of squares pattern that we're going to be factoring here. And then we have 3x plus 1 and then 3x minus 1. And I think this is as far as we could go. All right, so there you have 6 different practice problems on doing some multi-step factoring. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.